I came up with this question in one of the textbooks, and it was asked to solve this equation. And there's no number, there's all letters. My unknown is X, and all other letters A, B, C, D, E, F, G are constants. To start with this question, I will get rid of the fractions by doing a cross multiplication. Multiply diagonally equals multiply diagonally with the other two fractions. And it doesn't matter whether you start with this diagonal or with this diagonal. So starting with this one, ax plus b times gx plus h equals cx plus d times ex plus f. We need to expand. This is where the quadratic expression comes out. A times g, x times x. So that a gx squared. Ax times h plus a hx. B times gx plus b gx. And b times h plus bh. Expanding this side as well. Cx times ex is cex to the power of 2. Cx times f plus cfx. D times ex is plus dex. And d times f is df. I'm going to bring everything to one side. So we have everything on this side. Changing side and changing sign. So we have minus cex squared minus cfx minus dex and minus df equals 0. I'm going to factorize x squared. So ag minus ce. I'm going to factorize all my x terms now. We have one here, one here, one here, and one here. So we have x ah plus bg minus cf minus de. And my constants, the one without x, is bh and minus df. Bh, this one, minus df. But to solve this, we have to use the quadratic formula. If you remember the quadratic formula, if ax squared plus bx plus c equals 0, then x is given by minus b plus m minus b squared minus 4ac over 2a. So if I list my a's and b's, this is the formula. A is the coefficient of x squared. So here my a equals ag minus ce. My b would be these four terms, which is ah plus bg minus cf minus de. And my c, the constant, is bh minus df. And I need to fit these in that formula here. So to find the value of x, minus b, and b is all of that, which is AH plus BG minus CF minus DE plus or minus, again b to the power of 2, which is AH plus BG minus CF to the power of 2 minus 4, A, which is AG minus CE, and C, which is BH minus DF. So we have 4 lots of AG minus CE times BH minus DF. All that divided by 2 lots of A. 2 lots of AG minus CE. But this is the solution of this this particular question. So since all my constants were in terms of letters, so my solution will also be in terms of letters. I hope you enjoyed this solving this question. Till next lesson, bye.